If I could invite the gentleman to the stage, I'd like to introduce our first speaker, Matt Ellis.
Thanks, Anna.
Matt Ellis is Vice President of Research and Development at HERE Technologies, a pioneer in in-car navigation and mapping technology. Matt leads the company's application of machine learning, deep learning, natural language understanding, and knowledge reasoning. Matt holds a degree in theoretical physics and had 2 decades of experience at Amazon and at IBM, where he was once one of the chief architects of Watson and helped lead Watson's Jeopardy-winning program. Matt.
Thanks, Anna. Thanks so much, Anna. So I was going to connect the current state of the art in terms of autonomous driving and see how, as a consequence, this moves forward. So for those who perhaps don't know HERE Technologies very well, we actually have a long and diverse history in actually providing mapping solutions, navigation solutions, and location intelligence solutions. If you look at about 80% of vehicles on North American roads actually have the mapping solution and location intelligence solution from HERE embedded in them at the moment. And I was reminded of kind of an important point listening to Luke and Mike talk earlier about how do consumers respond and what do consumers expect in terms of autonomous vehicles going forward, by thinking in terms of how do you make sense of the world from an autonomous vehicle perspective. So a great example, you can probably catch by now that my accent picks me out as being a guy from London originally, who's moved to Seattle, who's acutely aware of location, who's acutely aware of location intelligence. So being a Londoner, those who have ever traveled in a London cab, one of those archetypal black cabs, and the cab driver, when you get in, you can give that cab driver the vaguest idea about where you're trying to go. In colloquial knowledge, I could say to that cab driver, take me to the Gherkin. And he or she would know how to get me there because they have the knowledge, as it's called. They have deep understanding of roads, traffic incidents, deep understanding of what it takes to navigate across the city, deep understanding about what happens in space and time, what happens during the rush hour, what happens in the afternoon. Another great example, having moved recently to Seattle in the last couple of years, I'm reminded of getting in a cab at the airport, and my wife and I were traveling to our apartment in Seattle, our new apartment in Seattle. And as we were driving down the road, the cab driver pointed out a building. Now that building happens to be at 1920 4th Avenue, Seattle, Washington, 98121. But can you ever imagine getting into an autonomous vehicle in the future and say, take me to 1920 4th Avenue, Seattle, Washington, 98121? No, you'd probably say, take me to the Escala building. Or actually, if you were more of a local, you'd say, take me to the 50 Shades of Grey building. Yes, it's the film location for 50 Shades of Grey. And we discovered this because the cab driver pointed it out to us. And later that night, when my wife and I were trying to find a great restaurant, somebody said, oh yeah, there's a great restaurant that's open late in the evening that's right next door to the 50 Shades of Grey building. At which point my wife and I are looking at one another going, why does everyone keep pointing this out to us? But that's location intelligence. It's built upon data that we accrue over our lifetimes, that we accrue on every journey, that's colloquial knowledge that we make use of. So one element of what does a consumer require when they get into an autonomous vehicle is actually this not only safety, not only convenience, but also a relationship with that vehicle that it's learning over time and that the fleet of vehicles is learning over time. And this is where here we focused on this. So this isn't a particularly controversial statement. Machine learning will be critical to self-driving cars. But perhaps map learning is actually vehicles that learn and understand the world around them and establish not just for each individual journey, but over time, what's happening in the world and what's happening in terms of location intelligence. So I promise this is the only eye chart I have, and you don't have to read it in detail. But the way to think about this is, how has navigation and knowledge about the real world, knowledge about reality that's happening in cities and suburban areas, changed over time and will continue to change as we further develop autonomous vehicles? So level 0, what we're kind of used to in terms of standard navigation, A to B, take me to this point. As we go into advanced driver systems and further adoption of level 1 to level 2 autonomous driving technologies, being able to understand what's happening around us, what's happening with the car in front of us, and also being able to judge road signs, judge road structure and geometry as well, and gather that information. Precise positioning and dead reckoning technologies that go with that. We're kind of at that stage today. It's fairly common in everyday vehicles, typical consumer vehicles. And as you see going forward, this idea of having a live, up-to-date map of the world, live, up-to-date understanding, the vehicle understands traffic incidents that are happening in front of us. As Luke and Mike were talking earlier about that connected vehicle that says 10 cars in front, there's a traffic incident, becomes increasingly valuable as well. Also, what becomes important is an ability to do on-demand updates to the map. Luke was talking about on the parkway, when suddenly the HOV lane changes direction, you would want your autonomous vehicle to know that A, happens regularly, and B, that it's actually occurred. Interestingly, living in Seattle, we have exactly the same approach to HOV lanes, and every time I see this happening, it terrifies me. And I want my autonomous vehicle of the future to know what's happening. I want it to have that colloquial local knowledge of the HOV lane changes direction on weekdays, therefore, what does it do in that situation? And as we push further forward in terms of highly autonomous driving, actually having not just daily updates to the map, not just having that colloquial knowledge about what happens on a day-by-day basis, but having much deeper knowledge and much more live knowledge of what's happening on the road around us. And also, what new pop-up opportunities are there? So think about the following example, which is not just take me the fastest route, but take me the most interesting route. How many people have ever hopped in a cab and the cab driver says, do you want to go the fast route on the interstate, or do you want to take kind of the nicer route, maybe a longer route, but it's less traffic, we'll spend less time in traffic as we travel. Okay. So you think in terms of challenges for autonomous vehicles and this notion of mapping or location intelligence for autonomous vehicles, not just precise positioning, not just beyond sensor visibility. So think about LiDAR, think about machine vision and computer vision at the moment. You also want to understand not just what's round the corner, but perhaps what's happening on other streets nearby and the consequences of that. Great example of this is actually a partner we're working with in Scandinavia who is using sensors on vehicles to recognize when there may be freezing conditions on a road, and as a consequence of knowing what other roads are nearby, understanding that they too may have freezing conditions on them. So informing other vehicles in the network, other connected vehicles, about the potential hazards that exist on nearby roads and nearby geographies. Then also understanding the rules of the road. Understanding that you have to move towards the right lane if you're going to take the next junction, and understand what the layout of the lanes are in terms of detailed lane geometry. It's not just simply there is a road that heads east or west, but understand that there are 4 lanes. The one on the left-hand side is an HOV lane. If I've only got one passenger in, I perhaps shouldn't be using that infrastructure. That level of rules of the road detail, the level of detail that says there may be a right-hand turn restriction or a left turn restriction at a particular time of day at a particular location. So if you think about the technologies that we often talk about when we're talking about autonomous vehicles, we often talk about sensing and perception and decision-making technologies, but actually having that location intelligence, what we colloquially refer to as mapping, that detailed knowledge actually becomes incredibly important as well. So how do we construct this? So here's an example of a video driving down a freeway. And what you can see is highlighted on this video is a set of machine learning technologies that are recognizing road signs, recognizing the boundary on the left-hand side, you can see a yellow line, recognizing street furniture like signposts, like lampposts, street lights and so forth. And that's actually kind of interesting from a perspective of this is what we as drivers may pay attention to as we're driving along. But actually, what does the vehicle see? So as you look at this, looking at recognizing vehicles on the street in red, recognizing the boundary wall, the median in blue, recognizing leaf structure, so tree structure that may cause visibility problems, the road signs and street signs in yellow, and then also being able to actually interpret the content of those. You'll also see road markings marked in white. So if you look closely, you might see the HOV sign going past in near real time and being recognized that that's an HOV lane and therefore has some rules of the road associated with it. And the consequences of this are each individual vehicle collecting this data, indexing the world as it's driving, recognizing objects and indexing the world, but at the same time sharing that information and gathering that information back into a live map, a high-definition live map of every object and infrastructure element, and what does that mean in terms of colloquial knowledge, and then being able to tie that back to that useful colloquial knowledge that says it's not 19 24th Avenue, Seattle, Washington 98121, it's actually the Escala building. So actually being able to tie that back and construct a map live from vehicle observations across many different vehicles, across shared information, and be able to recognize and understand road signs and understand the edges of roads and the road structure and the road geometry so that you can start making interesting decisions. That also means you can start making decisions about the optimal route on a road. You can start to do around the curve visibility and projection of what you may encounter shortly. So this technology exists today. It's available today. It forms the basis of the level 1, level 2, progressing into level 3 and level 4 availability of location intelligence and local knowledge in making decisions. But as you go forward, this ability to do live updates, this ability to make use of that, and also be able to heal the map, update the map based upon crowdsourced information becomes key. And then also be able to share that through vehicle networks and also share that and update it with sensor data as well. This is the state of the art today. Over the next few years, you see this growing in terms of adoption and more data being used. And with that, I'll hand on to the next speaker. Thank you.